from PID to evolution of process control. Process control is essential in industries like oil, gas, chemical processing, and manufacturing. Over the years, advancements in control systems have revolutionized how industries manage complex processes. The PID proportional integral derivative controller is one of the most widely used tools in process control. Introduced in the 1930s, PID controllers work by adjusting process variables based on the proportional, integral, and derivative values of the error. This method is simple, reliable, and effective for maintaining a process within a desired set point. However, as industries grew more complex, PID controllers started to show limitations. They could handle basic processes, but when it came to more advanced systems with nonlinear behaviors or multiple interacting variables, PID controllers became less effective. This led to the development of Advanced Process Control (APC) systems. APC is designed to handle more complex processes by integrating multiple control loops, optimizing performance, and adjusting for external disturbances. By using advanced algorithms, APC systems can improve process stability, efficiency, and throughput. APC techniques include Model Predictive Control (MPC), Real-Time Optimization (RTO), and Multivariable Control (MVC). These techniques allow for more precise control of complex processes, reducing energy consumption, improving product quality, and minimizing operational costs. In summary, the evolution from PID to APC represents a significant shift in how industries control and optimize processes. PID controllers remain essential for simpler tasks, but APC systems are increasingly being adopted to handle more complex, dynamic, and interconnected industrial processes.